So in the previous video, we have done this example. This one, two populations have the same mean, but the standard deviation of one is twice that of the other. Show that the sample of size 4500 each drawn on a simple sampling condition. The difference of mean will in all probability not exceed 0.10. And then we have to find the probability that the difference exceeds half that amount. So I'm rectifying this question. So when we want to find the probability of mod of z greater than 1.5, we want to find probability of mod of z greater than 1.5, right? So we have converted into its complement 0 less than mod of z less than 1.5. So this is as it is a symmetric distribution. So whatever we have in the area under the positive side, but we have the same area under the negative side. So we will write it like 2 times probability 0 less than that less than 1.5. So if I will mark 1.5 here, z is equal to, so this is the probability that we want to find. So in the previous lecture I have mistakenly covered this area because we want to find out the 0 less than in this only this area. 0 less than z less than 1.5. Guys, you have to, we are finding the area between z is equal to 0 and suppose z is equal to 1.5. Right? So this is the area. Is it clear? So between 0 and 1.5. So this we have the table value. So we will see from the table what value we will have. Then we will calculate accordingly. So just see. So the value under this z line between 0 and 1.5 is 0.433. So this comes up. So area that I have covered the previous was wrong, so I have rectified it now. Now we will continue with the proportion of. We have done the standard deviations test, all the tests. We have done the single proportion of population, test of significance of single proportion of population. Yes. So we were doing the examples. So here, this is a kind of derivation they have given. So first example we have given, we have done. Now we will come to the second example. In a sample of 1,000 people in Maharashtra, 540 are rice eaters. महाराष्ट्र पूरा महाराष्ट्र में से 1000 लोगों का सैंपल लिया और उसमें से 540 लोग जो हैं वो राइस खा रहे हैं. इसका मतलब प्रोबेबिलिटी ऑफ सैंपल प्रोपोर्शन ऑफ सक्सेस कितना हो गया 540 डिवाइडेड बाय 1000. यहाँ हम कह सकते हैं प्रोबेबिलिटी ऑफ अ राइस ईटर एंड द रेस्ट आर व्हीट ईटर्स. इसका मतलब कॉम्प्लीमेंट हो गया, 1 में से माइनस करेंगे वो क्या आ जाएगा राइस ईटर. Can we assume that both rice and wheat eaters are equally popular in the state? तो कह रहे हैं कि क्या दोनों जो हैं राइस और व्हीट ईटर्स वो दोनों क्या है इक्वली पॉपुलर हैं. इट मीन्स दोनों के यानी राइस और व्हीट खाने वालों की प्रोबेबिलिटी सेम है, मतलब उतने ही नंबर ऑफ पीपल राइस खाते हैं उतने ही नंबर ऑफ पीपल वीट खाते हैं. ठीक है. So whatever we have given, we will do accordingly. So we have given a sample of size n. X is equal to 540. These are the X. X is the X they have taken, given the sample of size n, 1000 people. Let X be the number of. X is equal to, नहीं लिखेंगे, we will write X with the number of rice eater, which is equal to 540. Then P, probability of rice eater. Yeah, P is the probability of sample success. So this comes out to be 0.54. Q, the probability not rice eater, probability of wheat eater, 1 में से minus करके आता है. So here, for in order to subtract from 1, you can use Nikhil's Sutra. To test whether the rice eaters and wheat eaters are equally probable or not, we set up the following hypothesis that पूछा क्या है, हम मान के चलेंगे राइस ईटर्स और व्हीट ईटर्स आर इक्वली प्रोबेबल. यानी पूरे महाराष्ट्र में ये प्रोबेबिलिटी ऑफ द प्रोपोर्शन ऑफ सक्सेस दे दिया हमें. पॉपुलेशन, पी इज द पॉपुलेशन सक्सेस, राइट. सो पी इज इक्वल टू क्यू इज इक्वल टू 1/2. सो H1 क्या आएगा ऑल्टरनेटिव, P इज नॉट इक्वल टू 1/2. अब हम टेस्ट स्टेटिस्टिक्स लगाएंगे. स्मॉल p माइनस कैपिटल P डिवाइडेड बाय स्टैंडर्ड एरर. We know the formula small p minus capital P and standard error is under root of PQ by N. As we have given the population proportions of success, so we will use P and Q. So after solving, you will get 2.5, and at 1% level, we have given 2.58. So calculated value is less than the tabulated value, so null hypothesis is accepted. So we conclude that rice and wheat eaters are equally profitable. So next is 400 eggs are taken from a large consignment and 40 are found to be bad. N is 400 and 40 are found to be bad. Let X be the number of bad. Let X be the, we will write let X be the number of bad X. This is equal to 40. Then the proportion of success, proportion of bad X in the sample is P is equal to 40 by 400. So you will calculate. Estimate the percentage of bad eggs in the consignment. Percentage क्या है उनकी consignment में total, and assign limits within which the percentage probably lie. So bad eggs की, that is we will calculate by standard error of proportion of bad eggs. क्योंकि हमें क्या निकालना, हमें एक इंटरवल एक लिमिट निकालनी है. उसके लिए हमें स्टैंडर्ड एरर ऑफ, उसके लिए हमें स्टैंडर्ड एरर ऑफ बैड एक्स निकालना पड़ेगा. ठीक है. तो उसका फॉर्मूला है. अब नाउ वी डोंट हैव गिवन द पॉपुलेशन, so we will use the sample proportion under root of PQ by N, right? So you will put all the values. This is 1.5. So 0.015 matlab 1.5%. So whatever may be the percent of bad eggs in the consignment, a simple sample should give a percentage within 3 times the standard deviation. So हमें अब जो एक लिमिट निकालनी है, तो लिमिट का फॉर्मूला बैड एक्स की लिमिट्स जो है, एस्टिमेट ऑफ बैड एक्स जो है, हमने क्या लेना है यहाँ पे. देखो स्मॉल p हमारे पास कितना था, 1/10. ठीक है. अब आप फॉर्मूला लगाएंगे. जो सिंपल आप फॉर्मूला देखो, उन्होंने 95% लिमिट्स नहीं पूछी, 5% नहीं पूछी, सिर्फ सिंपल वर्ड पूछा लिमिट. इसका मतलब यू विल राइट दिस फॉर्मूला. What formula you will use? Limits within which the percentage of bad eggs lie. So what you will use here? Small p plus minus. Here you are using 2.58 into standard error of p. Okay. P is 1/10 और स्टैंडर्ड एरर ऑफ p कितना आपके पास. अभी हमने कैलकुलेट किया. दिस इज 0.0015. So whatever value it will give, that will give the limits. So it means 5.5 to 14.5%. So required limits of this. So similar questions are on the same logic in some dice throwing experiment. A person threw dice 49,152 times. इतनी बारी डाइस फेंका और इसमें से and these uh, and of these 25,145 yielded a 4, 5 or 6. उसमें से इतनी बारी 4, 5 और 6 आया. Is this consistent with the hypothesis that the dice were unbiased? हम लेके चलेंगे dice को unbiased. Dice unbiased है, इसका मतलब probability of 4, 5 और 6 कितनी होगी? That is 3 by 6, which is equal to 1 by 2. So we set up the null hypothesis that dice is unbiased. So probability of success is not alternative hypothesis is not equal to 1 by 2. जो हमें दिया हुआ है वो सैंपल का दिया है. जो हमने H नॉट डिसाइड किया है कैपिटल P, वो हमें इस लाइन से पता चलेगा कि इज द डाइस इज दिस कंसिस्टेंट द हाइपोथेसिस दैट डाइस पर अनबायस्ड, कि जो डाइस है वो अनबायस्ड है कि नहीं है. ठीक है, उसके लिए जो प्रोबेबिलिटी ऑफ सक्सेस यहाँ पे आएगा वो हम 4, 5, 6 की प्रोबेबिलिटी में सिंगल थ्रो फाइंड आउट करेंगे. सो प्रोबेबिलिटी ऑफ सक्सेस है क्योंकि इतने ट्रायल में से इतनी बारी 4, 5 और 6 आया तो हम इसको डिवाइड करेंगे. सो we will not find it in the decimals. So here we will calculate. So now test statistics you will apply either. So this is you will apply the formula. You will get it is 5. This is a very big value, 5.13. So critical value of F at 5%, but two tail is 1.96. It is very much more. So null hypothesis is rejected. Next is sample of 900 days is taken from a meteorological records of a certain districts and 100 of them are found to be foggy. Let X be the number of foggy days. ठीक है जी. Then probability of foggy days कितनी आ गई है? Probability of sample success कितना आ गया? 100 by 900. ठीक है. This comes out to be 0.11. What are the probable limits for the percentage of foggy days? जैसे पीछे किया था आपने बिल्कुल वैसे. यहाँ सेम पहले आप स्टैंडर्ड एरर निकालेंगे. एस्टिमेट of the standard error of the proportion of foggy days. It is by the formula on root of PQ by N. So you will put the value, right? Then probable limits for the foggy days are, this is probable limits to the percentage. So percentage के लिए आप 100 से multiply कर देंगे. पीछे भी ऐसे ही था, 100 से multiply चाहे कर लेते हैं. So यहाँ पे formula वही लगेगा बेटा, P plus minus 3 times standard error of P. ठीक है, right?